A couple questions from the homework. Some of these are different in regards to the way the answer looks than what we've seen in the notes. Okay, but we approach them the exact same way. So if we think about the word "and," we see "and" in the problem. That means we are going to graph the overlap, right? Okay. If we see the word "or," that means all of both graphs, correct? Okay. If we abide by that, when we're done, we should be able to look at our third graph and come up with a very valid argument. Okay. So this first one, the only thing they're saying here is once you have that solved, and there's an "and" statement here. So this might have come from like x less than 1. Maybe that came from a different inequality, and you solved it down to this. X is greater than -5. Maybe that came from a different inequality, and you solved it down to this. But now they want you to, in this box right here, type it as a compound inequality. So they want something like this, where we've got less than x and less than something, right? So what should I put right here? What number? -5. Remember, this should be a number line. This should be a number line. So this should be the smallest number. This should be the largest. Does this here in green say the same thing that does right there? Yeah. And does this thing here in blue, does that say that right there? Yes. Okay, so that's all they're looking for there in that first one. Okay. In these other ones, you're going to see some things that we didn't really talk about in the notes in the previous examples, but my hope was that we use that logic of what and or means to us. So in this one, what they ask us to do is solve it first. So what am I going to do if I'm going to solve that first? And you're going to solve like an equation, so you're going to remove 1 from both sides, right?
Yeah.
So x is greater or equal to 6. Okay? Now we got the word "and." Now what are you going to do here? Add 1. Okay? So if I add 1, it's going to give me 4x is greater than or equal to 4. Then what are you going to do? Divide by 4. So x is greater than or equal to 1, right? So now here's the thing. If I look at that, it says x is greater than or equal to 6 and x is greater than or equal to 1. Okay? If you tried putting these in a statement where you had 1 here, you had x in the middle, and you had 6 over here, think about the way this is going to look. That inequality symbol needs to be pointing towards the 1, right?
Yeah.
This inequality symbol needs to be pointing towards the 6, right? Is that structure a problem to us? Didn't we say that when we write it as a number and then x and a number, that those inequality symbols should always be pointing to the left?
No.
Yes. That's a problem. Now here's the reason we will never write something that way, in that red box. Let's graph these. Let's use what that word "and" means to us. If I were to graph these individually, so we've got x is greater than or equal to 6, right? Okay, so let's put 6 here, and let's graph greater than or equal to, so it would be that stuff. Okay, let's graph x is greater than or equal to 1. So maybe 1 is here, and I would graph that stuff, right? Now in this final one, we're going to graph x is greater than or equal to 6 and x is greater than or equal to 1. Well, what does "and" mean? Go back up to the beginning. "And" is the overlap, right? Okay. Where do these things start overlapping?
Right there.
Right at 6, right?
Yeah.
Does that make sense? So when I graph the overlap, I start at 6, and I'll graph that way. Well, how do I describe that answer right there?
Greater than or equal to the number.
X is greater than or equal to 6, right? Does that make sense? Now think about this. So if I need a number that is greater than or equal to 1 and greater than or equal to 6, well, doesn't it have to be bigger than 6?
Yeah.
Yeah, because if I choose a number bigger than just 1, maybe I choose 3. 3 is bigger than 1, but it's not bigger than 6. And the and says we got to meet both. Okay? So, I think the thing that we saw in our notes and the practice problems and all that kind of stuff on Wednesday and Monday is that when we had an and statement, a lot of times we saw like going that direction and then over here they went that direction, right? And then the overlap was something like that. So we had the overlap being kind of a segment here. Your overlap doesn't always have to be that way. They can both be pointing in the same direction. Okay? So whenever you would write something like this potentially, okay, basically what we're saying is that one of those is really the answer. One of those is the best way of writing it. Okay? Because saying what I've got in this red box is exactly saying as what I've got highlighted green. Does that make sense? Okay. Okay. Let's do this one. So it's a similar idea. Okay. Actually, that one's going to be. I don't want to do that one. Let's do something like this. Let's say I've got. And this is going off the same logic. Let's say I had x is bigger than or equal to 3 and x is less than or equal to 0. Give me a number that is bigger than 3 and at the same time is less than 0. Is that bigger than 3?
Wait, did you say bigger than 3 and less than 0?
Yeah. That don't make no sense, right? Okay. So here's the idea. Now, if you're having trouble thinking that, we have the word and, right?
Yeah.
X is greater than or equal to 3. That would be, let's say 3 is there, and we're shade that direction, right?
Yeah.
X is less than or equal to 0, so maybe 0 is there, and we're shade that direction, right?
Yeah.
If I do X is greater than or equal to 3 and X is less than or equal to 0, it's the overlap, right?
Yeah.
Where do they overlap? Nowhere. Okay? So that's why there's no answer to that. Okay? Because it kind of contradicts the idea of how we compare greater than and less than things, right? You can't be bigger than 3 and at the same time, so be on the right-hand side of 3, but also then be on the left-hand side of 0. That doesn't make sense. Can't happen. Okay? Another situation could be this. Let's say that I've got a question here that says x is less than 2 or x is less than 4. X is less than 2 or x is less than 4. So let's graph those individually. So if I want to say x is less than 2, let's put 2 there, let's put 4 there, and x is less than 4. So less than 2, open dot or close dot? Open, shade which direction? Left, right? Okay, so should be that. Okay? Now, if x is less than 4, open or close dot? Open, shade which direction? Okay. Now, if I wanted to graph the phrase x is less than 2 or x is less than 4, okay, the word or meant you graph all of the first one, which would be at 2 going that direction, right, along with all of the second one, which would be at 4 going that direction, right? Okay. Now, initially, this dot was open, right? But when I graph this one here and go that direction, it closes it off. Okay. So now everything to the left of that number 4 has been graphed. So when I look at that, what is a better way? What's a more concise way of representing those red answers? Well, if I say that,
because it's all together.
Does that make, we look at everything that's been graphed, okay? So here's the idea. If I give you a value of x that is less than 4, the idea when we said or is that it means we could pick off any number in this red, and it's going to work for one or the other of these, right? And in some instances, it might actually work for both of them. So let's pick a number. Give me like number, like let's just try 0. Is 0 less than 2? Yes. Okay. Now it worked for 1. I don't need to check the other one, but look, if I check the other one, does it work there too? Yeah. Okay. If I try 3, now 3 should only work for that one, right? So if I put 3 in here, 3 less than 2, nope. Or 3 is less than 4. Yes, it works for that one, so I'm okay. Okay. So there are some values that will work for both of them, or some that will work for just one of them. And with the or statement, that's what we need. We need at least one yes when we plug our answers back into, or plug our x values back into our original inequality. Okay? So this is a more concise way of writing that. Okay? Does that make sense? All right, so let's try this one. Okay? X is greater than 1. So let's put 1 there. Open or close that? Open. We've got x is less than 3, so let's put 3 there. Open or close? Okay, so they're all open. So if I go open this direction and shade that way, and then I go open in this direction and shade that way, when I put them together as the word or says I should, right, are there any values that do not get left out, right? So I'm going to put all of this one. So on that one, 3 is to the right of it, right?
Yeah.
And 3 on this one's open, but when I put this solid one through it, it closes that open one, right? 1 is open, but when I graph this one here when x is less than 1,
So the whole thing is out.
or sorry, I got this backwards. That should be a 1, and that should be a 3. Okay? When I shade left of 3, it closes that one in, right? So are there any numbers on that number line, that last number line that I left out? Okay, you put a million in there. Million is bigger than 1. So there's not a single number up there that you can pick off that would not work for one or both of those inequalities. Okay? So no matter what number you pick off of that blue number line, which is all real numbers, okay? Huh? It's not, but it's great. It's less than 3. So it works for that. You only got to have one yes. Okay? So it gives you 0, gives you a no there, but it gives you a yes there, so we're okay. So it should be a solution. This okay? So those were a handful of questions that were being presented in the homework that some of us may have struggled with. Okay, so I want to make sure that we touch base on this. Now, here's the thing. Has anybody in this class taken Algebra 2 before?
Yeah. Yep. Yeah.
Should all be resounding no's, right? This is Algebra 1. So here's the thing, and even none of you have taken geometry yet. Okay?
Have you?
Yep. Once or twice. Once or twice. So here's the thing. This is the reason I asked this. I have taken those courses. I have taught those courses. I currently teach those courses. And I know the structure of those courses. You're going to see what we just did again, but in greater detail in Algebra 2. In geometry, we're going to talk about that stuff again, but with geometric concepts. Maybe talking about the segments of a triangle, the sizes that they're allowed to be, okay? And that kind of stuff, okay? So when we talk about, like, just give you an example when I say sizes of a triangle. If I were to give you 3 segment lengths, okay? So let's just say I give you that segment length, that one, and maybe that one, okay? And I ask you to put them endpoint to endpoint. Do each of these have like a length? Okay, well, here's the thing. If I put those endpoint to endpoint, they're probably structured to where they won't be able to do that, right? Okay, I could put any 2 endpoint to endpoint. Okay, so maybe I take this first one, and put it like that, and then take the second one and put it like that, right? But is this third one going to be able to connect the remaining? Okay, so this one's not long enough, okay? Or maybe we argue that this one's too big, okay? Or this one's not long enough. The idea with making, if I were to give you 3 segments of any length and ask you to make a triangle, you can't do it. What has to happen is if I give you 2 segments, let's say this one is 3 feet long and this one is 10 feet long, okay? The third side, I'll just call it S. The third side has to fall within the difference of these 2. So 7, if I subtract those, right? And 13. So this third one has to be either 7. 7 is the, it's got to be greater. So it's got to be like 7.0001, okay? So it's got to be bigger than 7 and less than 13 for you to actually make a third side for this triangle. Does that make sense? Okay? That's an inequality though, right? Okay? So what I'm trying to get at here is, right now in algebra, it's kind of like weightlifting for football, right? Okay? You don't, when you go to a football game, do you get a bench out, you get a squat rack out, you get dumbbells out on the field and start using them?
If I did, there'd be
No.
a lot of injuries.
Okay? To you, probably.
No.
Okay. So, you don't do that, right? But the weightlifting that you do in the summer and the spring and all that kind of stuff prepares you for using your body in a game some point, right? So Algebra 1, is preparing us to be able to actually use this math in a meaningful way when we get to geometry. Okay? And then we'll learn more stuff in Algebra 2, and we'll then use that meaningful algebra in Algebra 2 inside like pre-calculus or stats or calculus, trigonometry, okay, which is, if you stay in the integrated course, it'll be integrated 3, integrated 4. So I want you to understand that this stuff's going to repeat, okay? You're going to see this stuff again over and over and over again in the next couple of years. All right. So we're going to move on to the next idea. So the next idea is absolute value. You guys know what absolute value is?
Yes, the 2 lines beside the numbers.
They make it positive.
Okay, so absolute value either keeps the value positive or makes a negative value turn into positive, right? Okay, so that's probably the way you've been taught, okay? And that's fine, but the reason we do that, the reason we say that is absolute value is actually referring to the distance. The distance something is from, and the way we're talking about from 0, okay? The distance something is from 0. Think about this. If we start, let's say Lima is our 0. It's our starting point. And you travel 30 miles east of Lima. Would you have traveled the same exact distance that somebody would have traveled 30 miles west?
Yeah.
Okay. Now, if I make that another line, east being positive, west being negative. Okay? So the idea is absolute value refers to the distance something is away from 0. Distance always has to be a positive number.
Yeah.
Make sense?
Yeah.
No matter where you start at, if you're going to drive somewhere, even if you do it in reverse, you have covered a positive amount of ground. Okay? You've covered a positive amount of distance. So that's what absolute value is defined as. It's the distance something, and when I say something there, we're talking about our either x, our variable, or our unknown, or whatever. It's that object's distance away from 0. Okay? So that gives us 2 answers. Every time we do an absolute value equation, you're going to have 2 answers. Okay? Unless you are right on top of 0, you only have 1. But we have two answers, and the idea is one answer comes from you moving to the right from 0. Okay, so moving 30 units to the right of 0. And the other one comes from moving to the left of 0, 30 units to the left of 0. So that's that negative 30. Okay? The idea of negatives, guys, that negative, that symbol of that minus sign out front is telling us a direction. You moved to the left. Okay? The plus is a direction. Move to the right. Okay? So here's by definition what absolute value is algebraically. Okay? Says by definition if the absolute value of A. Okay? Now when I say A here, that is my something. That's something right there. Could be A, could be X, could be 2X, could be X plus 5, could be 2X plus 5. I don't know. It's just some object inside the absolute value bars. If it is equal to some other object C, okay, then we can make this conclusion here. Okay? So I want to talk about that green statement because this is kind of maybe one of the first times we've really seen a statement like this that we're going to apply to get some equations that we can solve. This is called a theorem. Okay? Now, when you get to geometry, the way I teach geometry is basically it's a way I use geometry as a subject to teach you how to read mathematics. Okay? The word theorem means that it is a statement that you can support with proven facts. Okay? But the way every theorem is structured, guys, is it's going to have the word if, and then it'll say something. After it says something, it'll have a comma. It'll then say the word then, and it'll say something else. Okay? We call this our conclusion. Okay? And we call this our hypothesis. Have you guys heard those words before? Okay, you've dealt with if-then statements? Conditional, maybe called conditional statements? Okay? Here's what we do. This is the reason you've maybe learned that, is that all the mathematical rules that we come across are going to be written this way. And basically it says, if you have a problem in front of you, your homework, your notes, whatever, if your problem matches that hypothesis where it says absolute value of something equals to C, if that's what the structure of your problem looks like, you can then take your problem and do what the then part of the theorem says. Okay? So here's what I'm getting at. If you have something like this in front of you, let's say we have absolute value of X equals 5. Okay? Does that match up to that image right there? You have the absolute value, and that A, now for us, the A is X, right? Does that make sense? For us, the C is 5. That is happening in front of us. If that's true, then we can say for our particular problem, X, which was this A, right? The X is the thing that's inside the front, or inside the absolute value. So I say X equals C. Well, if I look at this problem, okay, just look at all of this real quick. Does this here and that there, are they ultimately the same thing except for I got rid of the absolute value bars? Yeah. Okay, so if I had absolute value of X equals 5, don't I just get X equals 5? Get rid of the absolute value bars? Yeah. Okay, and what that does for us is it gives me an answer that is to the right of 0. 5 units to the right of 0. Okay, but there's also a situation that we could be 5 units to the left of 0. So that's where we get this. So I write the word or, and I go back, okay, what was the thing in the absolute value bars? For us, it was X, so I put X. And then what was my C? It was 5. But now this says to make it negative. Okay? So if I have that, if I have absolute value of X equals 5, then we get X equals 5 or X equals negative 5. We're going to get two solutions here. Yes. They're two different answers, but they're both 5 units away from 0. Yes. The picture here of this definition says if you start at 0 and you find C over here, and you find negative C over here, okay, we're saying that distance and that distance would be the same. Okay? Alright, so, as we do these problems, okay, we'll continue to talk about that logic and that idea. Once we get an answer, we'll go back, we'll draw our picture up, say, does this make sense to us? And hopefully we realize that we're going to have an answer to the right of 0 and an answer to the left of 0. As we move on through the course, and we haven't done a whole lot, as I gave you that handout for the this thing here, okay, steps to, if you get stuck, what to do, right? Here are steps that if you're working with absolute value and you get stuck, these will get you unstuck, okay? The first thing we need to talk about is absolute value. Absolute value, we treat those as kind of like parentheses at the beginning, okay? And when we evaluate expressions with absolute value, we treat them like parentheses. They tell us to work with those first, okay? So here's a quick question for you. If you had, like x plus 3 in parentheses plus 6 equals 4, what would you do first, or what's an option you could do first? Okay. But is there anything you can do there? Now distribute means I have to multiply. I have to have this has to be multiplied by 6. Okay, so I could regroup these and write it as x plus 9, right? Okay. Could I do this though?
No.
Can I move that 6 over there? Does that make sense? Okay. So the idea is that when I have absolute value of x plus 3 plus 6 equals 4, I have to do that. I have to move that plus 6 over first. Does that make sense?
Why?
Because of the way absolute value works. Okay? Because absolute value is going, when I want to solve for x, we need to be able to use that theorem that we just talked about. And that theorem says that your absolute value bars, okay, these things, they had absolute value of a, right? They have to be by themselves. They didn't have absolute value of a plus some number, right? It just had absolute value of a. It had absolute value of something that had to be on the left-hand side all by themselves, okay? So that's what step 1 says. Do everything necessary algebraically to isolate your absolute value symbols, okay? So in that first step, maybe you even think about your absolute value symbols as kind of being a variable. You need to get that by itself, okay? Or maybe it's a bubble around some part of your equation. You need to get that bubble by itself, okay? Step 2 says, get rid of the absolute value bars and solve the remaining equation. And what that's going to do is that's going to give you the answer that's to the right of 0, okay? So it gives you half of your answer. Step 3 says go back to the equation that you just found in step 2, rewrite the whole thing without the absolute value bars, but make one side negative. Okay, multiply one side by negative. And what that's going to do is going to get you the answers to the left of 0 on your number line. Okay? You then graph and write your answers as a group of 2, okay, as a set. Okay? All right, so here's the idea. When we look at this here, okay, we're going to try to use that rule that said if the absolute value, I'm going to use x now, is equal to c. Now let's do it this way. This might be, instead of the algebra, let's do this. Let's put the absolute value of something, or just write the word something, is equal to, let's say, c. Then we get 2 answers. We get the first one is going to be, or 2 things. The first one is going to be something equal to c. You're going to get that something that's in there equal to c. The other thing you're going to get is your something equal to the opposite of c. Does that make sense? The more involved we get with our algebra, that something can be more algebraic. Instead of just x, a lot of times we call it ax plus b, but it's going to be some expression. Okay? And maybe writing the word expression here instead of the word something might be better. Okay? So, in order to do this, in order to get to these 2 things, because these 2 things are going to provide me my work to do my answer, I need to make sure that my problem has the absolute value bars by themselves. Does that make sense? And then equal to that c. Okay? So, how do I get these absolute value bars by themselves? Subtract 2. So, that's going to give me that then, right? Okay. Is this now absolute value of something equal to some number? So the first equation I get is just that without the absolute value bars. So you drop the absolute value bars and you're left with that. Okay? Now, this isn't very interesting because there's no algebra to do here. There will be algebra eventually to do here. Okay? The second part then says take this result, whatever that equation is, and make one side negative. So I'll make the side with the constant on it negative. And that gives me my two answers. Okay, now here's the thing. And here's the reason why we have to isolate the absolute value bars, because it's how we evaluate. When I plug 7 in here, okay, I have to take the absolute value of 7 first. These absolute value bars in regards to evaluation are like parentheses in order of operations. So what is the absolute value? If I put this answer of 7 in here, what's the absolute value of 7?
-7.
Absolute value always keeps it positive, right? Okay. Gentlemen, wake up. Both. Hey, wake up. Kyle, you too. Both of you. Absolute value of 7 is 7. Stays positive. Add 2 to it. What do you get? 9, right? Okay. Take this answer, -7. What's the absolute value of -7? 7. Add 2 to it. 9, right? Okay. So that process of having to take the absolute value first before I add a 2 is the reason that we need to isolate that when we're solving. Okay. So, that being said, go ahead and do that next one. Do the absolute value of n minus 5 equals -2 on your own. Yep. So we're gonna isolate that, right? We'll get that by itself. So what you gotta do first. Okay. And that gives me absolute value of n is equal to 3. Okay. So -2 plus 5 is 3. So now this looks like our rule, right? We've got something equal to c. So then I just take the first equation is going to be that something equal to 3. And my second equation is going to be that something equal to 3. But now I have to negate one of the sides, right? Which side does it make most sense to get my answer the quickest? The 3, right? Now it doesn't matter, because here's the thing. If I go n equals 3 and I negate this side, but keep in mind my overall goal is to solve for n, right? Would you multiply this side by a -1 to get n? Multiply that side by a -1? Does it still give you n equals -3? Okay. So it doesn't matter which side you negate, okay, when you do that second equation. But there are, I think, more logical sides to decide. I always go to the side that has the least amount of things on it. If I've got three things on the left-hand side, 2 on the right-hand side, I'm going to go multiply the right-hand side by 2, or by negative, because that only has 2 things. If I have 3 and 1, I'm going to go to the side that has 1 and multiply it by negative. Okay? It just minimizes your work if you do that. All right, so I'm going to skip this and we'll come back to it. I'll come down here to this one here that says 3 equals m plus 2 minus 4. I'm going to rewrite this. We're going to rewrite this as the absolute value of m plus 2 minus 4 equals 3. I think at the beginning, people like to see the absolute value stuff show up on the left. Okay? So, if I'm going to isolate my something, okay, my expression here in the absolute value bars is equal to c, okay? To get my 2 results that say expression is equal to c, and my second one says expression is equal to the opposite of c, what do I have to do first here?
Add 4.
Add 4. So now I get the absolute value of m plus 2 is equal to 7, right? Okay. Now, m plus 2, is that an expression? Yes. Okay. So, I'm going to write my first equation. It's going to be the m plus 2 equals 7, and all I do is just get rid of the absolute value bars, right? So something that you might recognize, I tell my college algebra kids this all the time, you're going to get 50% of these questions right if you just completely ignore the absolute value bars and solve. Does that make sense? Okay. Now, obviously, if we get all 50% on every question, we got 50% on the assignment, and that kind of sucks. So now the same thing. I don't solve that right away. I always create both equations right away. Because in the second equation is this thing again, so I just rewrite it. But now I'm going to multiply one of these sides by a negative. Which side makes most sense to multiply by a negative? The 7, right? Going off of that argument that we choose the side that has the least amount of objects on it. So now, the reason I do both these equations first is because how are you going to solve for m here? Subtract 2. And that gives me m to be 5. What are you going to do here? -2. Okay, so it's the same exact algebra, isn't it? Okay, now your combining of like terms is going to be different. -7 minus 2 is -9. Okay, but those are your two answers now. So we write m is equal to 5 and -9. If they ask you to graph these, which some will, okay, we're going to go find -9. On our number line, we're going to find 5. We have what we call a finite number of solutions. Infinite means you cannot count, right? Nobody in here can count to infinity. So when you have an infinite number of solutions, you cannot count how many you have. But if I have a finite number of solutions, that means they're countable. That means I can tell everybody I've got 2 solutions. When you are able to graph finite solutions, you just do it with a dot. So at -9, I'm going to close in a dot. At 5, I'm going to close that dot. Does it make sense? Okay. Showing infinite solutions, we have to use that shading of the number line. But finite, we just put the dots. Okay. Now here, think about this. They're not. If I put a 0 in here, how many units from 0 is 5? 5. How many units from 0 is -9? 9, right? So that kind of maybe doesn't address what we said early on about absolute value. Okay? The distance something is away from 0. The thing here is that's putting the m plus 2. It's not just a variable of m now, or the variable of x, or a, it's m plus 2. So really what we've done here, if it's m plus 2, we have put, okay, m plus 2, 7 units away from -2 instead of starting at 0. Does that make sense? If I start at -2 and I walk to 5, how many units do I walk? -2, 2, 5. -2, 2, 5 would be 7 units, right? -2 to -9 would be 7 units, right? Doesn't this say m plus 2 is going to be 7 units from something? Does that make sense? Okay. So that's the procedure for doing that. Let's do well, hold on, we got some stuff right here.
Distribute.
No.
Oh.
We don't. So absolute value, you're never going to distribute with absolute value. Okay. I want to get those by themselves. Okay. I'm going to remove 12. Okay, so now I got 3 times the absolute value of 2z plus 9 equals 9, right? Okay, now is that absolute value of an expression equal to c yet? No, so I need to keep going. So what do I need to do now? I need to divide. So this 3 here, guys, this 3 has there's no symbol between 3 and the absolute value, right? So it means multiplication. Okay? So I'm going to undo that through division. So those cancel. And now I have the absolute value of 2z plus 9 is equal to 3, right? Okay? Absolute value of 2z plus 9 is equal to 3. Is that an expression equal to c? So now we can do our two equations where it says expression equal to c and expression equal to the opposite of c. So my first one, 2z plus 9 equals 3, right? Just drop the absolute value bars, and I get that equation. The second one is the same exact equation, 2z plus 9 equals 3, but I make the 3 negative. Good. Can we solve these now? So at that stage, it turns into algebra from chapter 2. Subtract 9 from both sides here. So we get 2z is equal to negative 6. And then what? Divide by 2. So then z is equal to negative 3. Okay, so here's why I do both. I create both equations first. Because I subtracted 9 here, right? What are you going to do over here? Subtract 9. It's the same algebra both times. So 2z is equal to now negative 12, right? What am I going to do next? Divide by 2. I divided by 2 here, right? Got to do that again here. So z is equal to negative 6. So those are my two answers. Z is equal to negative 3 and negative 6. Okay. Quick question. What do I do here on this one? This last one. Add 5. Add 5. Okay. Now, at that stage, and this is something we're always going to be thinking about, because you're going to see some of these. We usually read this absolute value of 3x minus 6 equals negative 2, right? But absolute value, by definition, is the distance, right? So I'm saying right here, the way this is written is that the distance that 3x minus 6 is from 0 is negative 2 units. The distance that 3x minus 6 is from 0 is negative 2 units. Can distance be negative? No. Okay. So this is a special case here. This is a trick question. And you're going to see this a lot. Okay. When I say absolute value of 3x minus 6 is equal to negative 2, there's nothing there. You can't do that. There's not a single number you can put in here that when you evaluate, okay, so a lot of people think 4/3. If I were to solve this without the absolute value bars, I get 4/3. Put 4/3, do it 3 times 4/3. What happens with the 3 and the 3s? They cancel out, don't they? So 3 times 4/3 is 4. What's 4 minus 6? Negative 2. Okay. But what's the absolute value of negative 2? 2. And this says it should be negative 2, right? See how it's not going to work? This is always going to produce a positive number, right? Absolute value always produces a positive number. There's no way that it could be negative. Okay? So that is a question that you cannot answer. That's no solution. That's what we write there. Okay? You're going to see those. They're going to try to trick you. Okay? On a test or a quiz, every class that this is used in, every aspect of absolute values that gets used here, gets used in geometry, gets used in trigonometry, college algebra. Okay? Whenever you deal with this, there will always be a question on a test that is like that, and they try to get people to answer 4/3 or something like that. Okay? Where the answer is no solution. Once you have absolute value isolated and it's equal to a negative number, absolute value can never be negative. Okay? There's an assignment on Math Excel. Okay? Do tomorrow evening. You can go.